All right, longest increasing subsequence. So I'm going to go over the top-down dynamic programming approach. And before I get into anything, I'm just going to go over the recurrence relation. So if we want to find the longest increasing subsequence at index 0, then this is going to be equal, like what is the length of this? This is going to be equal to 1 because we're selecting one thing to be in our subsequence. 1 plus whatever the maximum length of the LIS is at, say, index 1. What is the length of the longest increasing subsequence starting from index 2 all the way to, say, n minus 1, or LIS of n minus 1. Okay, so like this would give us the length of the longest increasing subsequence starting from index 1, starting from index 2, starting from index n minus 1. Then we take the maximum and then just add 1 to it because we selected one thing so far to be in this increasing subsequence. And yeah, that would give us the length of the longest increasing subsequence starting at index 0. Now, if we wanted to generalize this, and actually, yeah, let me just keep going. But there is a condition to these, but let me just try to generalize this a little bit. So this would be 1 plus, say, the LIS at I to I plus 1 to, say, n minus 1. And the starting position so I would start at, it would start at index 1, right? Because we already took index 0 here. The longest we started from index 0, and now we start from index 1. So that's why I said start I equals 1 all the way to, say, n minus 1. But we have to also say where the last thing in this subsequence, so you could say like where let's just call it last, is less than the starting number in these subsequences. So for example, it'd be like where the last thing is less than nums at I. And because it has to be an increasing subsequence, right? Like the starting point, the starting value in these sequences have to be greater than the last thing in the subsequence in order for it to be increasing. So that's roughly what our recurrence relation is. And we're going to do this for every, we want to try this for every starting point. So we want to say, so we tried our starting from index 0. Now what happens if we start, say, from index 1? So we'd want to find the longest increasing subsequence starting from index 1, which would equal 1, because we only have one thing in our subsequence so far, plus whatever the maximum is of the longest increasing subsequences from I to n minus 1, where start I, in this case, would equal 2, because we started from index 1, so that at most this could be index 2 here. Or at the smallest value this could be was index 2, all the way to n minus 1. Okay, so and then we're going to do this for, say, all the way to LIS of n minus 1. And this would just equal 1 at the end, right? LS of n minus 1 would equal 1 because there is no more values to choose. And then we would just take the maximum of these values here. And that would give us the longest increasing subsequence. Okay. So I'm sorry if that's a little rough. Maybe like work through it a little bit. But I'm just going to code it out and hopefully it's a little clearer. So yeah, let's just write the recursive method. So private int lis. We need to pass in the nums array. We need to pass in the start I. And we need to pass in the last thing in our subsequence that we added. Okay. And we're going to just say return lis nums, pass in 0 as our starting point from the beginning to the end of the array, and pass in the min value. Okay, and the smallest number in nums is going to be negative 10,000 according to the constraints, so this won't cause us any problems by just passing in the min value here. Okay, so now we want to try every starting point from start I. We want to find the longest increasing subsequence from every start I position, or from start I to the end of the array. So we're going to do int I equals start I. I is less than nums.length plus I. And if the last thing in our subsequence is less than nums at I, then the length of this subsequence is going to be 1 plus lis of nums I plus 1. So this is 1 because we're adding this number to our subsequence. We're simulating adding this number to our subsequence. So that's where this 1 comes from. And now we're going to say, okay, now go ahead and try starting from all the other positions at I plus 1 to the end of the array. Okay, and our last number is just going to be nums at I, because we're saying that we've added this number to our subsequence. Okay, and if length is greater than, say, our longest subsequence, so let's just declare a variable up here, so longest equals 0. So if the length of this subsequence, or if the length of this subsequence is greater than our longest subsequence so far, then just set longest equal to the length. And then we're going to return longest. Okay, and last but not least, so that we, so this doesn't take like forever to run, we're going to memoize this. Okay, so we're just going to create a map. And let me explain what this is going to hold. Let's call this memo. So the first integer in our map, or the key in our map, is going to be the start I. And this is going to be mapped to the thing that the length of the sequence when we started at I, at this index. So we're going to do memo dot put start I longest, and we need to check if memo dot contains key start I, then return memo dot get start I. Okay, and let's just run this, see what happens. What's wrong with this? Return LAS. Oh, I forgot to pass in the hash map. Okay, new hash map for the memo. And what's wrong with this? Oh, I need to pass in the map again. Memo. Okay. All right, cool. Let's just submit it. All right, awesome. So that's the top down. Oh, and then we should go over the time complexity really quick. So first, let's talk about the memo map. So the memoization map can hold, it's going to hold n elements, right? Because it's just holding the index, start I, which is an index in our nums array. So our memo will only hold index, or the keys 0 to n minus 1, which is essentially just n elements. And that means that we're only going to execute this part of the code at most n times. So if we're only executing this n times, we just need to know what the time complexity of this guy is here. So the time complexity here is going to be O of n, because we're just looping from start I to the end of the array. And if you want to get really mathy with it, you can see that as start I increases, the number of operations of this entire for loop decreases. So this would be, say, like n operations. So this would be like n operations plus n minus 1 operations plus n minus 2, all the way to 1 operation. And this whole sequence would just equal, like 1 plus 2 plus 3 all the way to n is just equal to n times n plus 1 over 2, which is equal to n squared plus n over 2, which is just big O of n squared. So our entire algorithm here is just n squared, the entire thing. Okay, so hopefully like that's in depth enough, but yeah, so now I'm gonna, probably in the next video, I think I'll go over the bottom up solution. All right, bye.